Oh, wait, hold on. They might be excluded. And I'll talk to you guys about that in a second. Here we go. There I am falling down the stairs. Okay, so there's exemptions and exclusions. Did you know in Health and Safety Code it says a waste that is solely classified as hazardous just because of TTLC, and we're not talking STLC, it's not soluble, so just because of totals concentration, it's just one metal or one item, then, and the landfill will take it, then it can be disposed of and it should be excluded from the classification of hazardous waste. I don't know if you knew about that, but that made me fall down the stairs one day. So, yes.
Okay, like let's say, example, you have a cooling tower that's got treated wood.
Okay.
And there's a dispute, so you analyze it we've analyzed it for TTLC. And they came back with chromium of about 2,400 milligrams per kilogram. They came back with copper a little less. We decided, okay, we ran the STLC also. And it definitely was over because the chromium was just under and the copper was just under, but we went running the STLC. So, but it could have gone as a treated wood waste to, I think, I forget which class of a solid waste landfill. So you're saying that if
use the microphone if you could.
the question, so would it be, if we had just ran the TTLC and it came under, we can still send it to the class 1 landfill based upon what you're saying?
Possibly, it depends. So you're asking, I hopefully captured the question, but one of the things to keep in mind on this exclusion is it could be hazardous for other things. If it's hazardous, and it says that in the fine print down here, and in the law it says that. If it's hazardous solely for that one item, right, then it might be able to be determined as and the landfill will accept it, then it might be able to be determined as non-hazardous. But you have to jump through all those hoops.
But would it have been appropriate to run it for STLC to confirm, because it was just
maybe
under the TTLC?
Yes, 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 yes.
So
yeah.
If you take a chunk of tire and you cut it and you run it in TTLC for zinc, it'll fail for zinc, but not the STLC. So you can take that tire and throw it in the landfill.
So a tire might fail, if cut up a tire and send it to the landfill, if it just fails for zinc under totals, it's not soluble, and the landfill will accept it, then you're right. And that's what this exclusion is focused on. But really, and we can get into a lot of discussion, but all I'm trying to point out here is that there's exclusions. And you may think you have it all figured out, but just remember that sometimes there's exceptions to pretty much everything. So if it doesn't exceed the TTLC, are we done? Oh, I'm sorry. Question in the back? Oh, yes.
Yeah, I just had a quick question. On that tire example, that's an interesting example because you have something that isn't a finely divided metal. Sorry, I'll start that over. Okay. So I think that tire example is actually an interesting one because you're talking about zinc in a tire. Mm-hmm. So in that case, that's not a finely divided metal, right? So if I have a bar of lead or a bar of zinc or whatever I have, right, and it's not a finely divided metal, it's at that point it's a non-issue, correct?
Well, this class isn't talking about what is a waste. It's not talking about recycling exemptions. I mean, you could think of, we could sit here for hours and come up with all of the different exclusions, definitely. What you're saying is most likely true. But in looking at lab results only, specifically, just remember you may get results that are showing, like that result we showed a minute ago, 110,000 milligrams per liter of zinc, but if there's an exclusion, then it may not be what you think it is. So I better get moving on here. Good questions, thank you. So the California rule does have a rule of thumb as well. For EPA, it's the 20-time rule. For the California, it's the 10 times rule. So you can take a result for totals and divide it by 10 to decide if you should run the STLC. And hopefully a few of you are familiar with the way that works. This presentation gives you a quick, we can practice it here. So you have those total results. Now let me ask this, why wouldn't you just run STLC on everything? Why? Why wouldn't you just run STLC on all the metals for your sample?
TTLC is a total digestion.
Okay, but it's a totals.
You could take a chrome bumper from a car and run an STLC and you won't find any chrome. If you run it TTLC,
Okay,
it will show up.
right, but I'm not going to talk about, chrome bumpers. That, that obviously we're looking at, let's say it's a powdered waste that you're generating. Let's say it's sandblast waste from a shop that processes classic cars, okay?
Solubility.
Okay, so you have a totals, you're going to run that result. Why wouldn't you just run STLC on all those metals, all the 17 California metals? Price, yes, it's very expensive to run STLC on every single metal because Patty has to pull out her big machines and it takes a lot more time and they have to do the digestion steps and all of these things. So to run the totals first is your guide to kind of steer you in the right direction. You look at what metals there might be a concern with and then you can focus those more definitive tests in that way. Okay. So here we go. We have a result here, a totals result for copper of 1,800 milligrams per kilogram. And so what we're doing is we're looking at this result. We're taking the soluble threshold. We're multiplying that times 10. And we're deciding whether we should run the STLC. So let's give it a try here. Oh, I'm sorry. Okay. What's that?
It's over on the side.
Okay. All right. So over here you have on the right-hand side, see your STLC limits. Everybody see those? So you can see for this result that if you multiply the STLC times 10, the STLC limit times 10, then you would see that you probably do need to run this result for copper for STLC. So down here at the bottom, and zinc. So look, well, zinc has already exceeded. But down here for copper, we ran the STLC for copper just to be on the safe side. And some labs will bold those results that are exceeding 10 times the STLC. They'll bold them on the list to kind of help you go, oh yeah, this one's 10 times the STLC. And then you'll know, okay, that's the metal I should run STLC on. But in this case, it came back non-detect for copper under the STLC test. All right. Now, let's talk a little bit about the footnotes. And I want to talk about asbestos, barium, and molybdenum disulfide. That's a hard word. So for asbestos, the trick there is it has to be, you may get a result for asbestos, okay? But if it's not considered friable, powdered, or finely divided, and this gets to some of the questions you guys were mentioning earlier about finely divided and that kind of thing, then it's not going to be considered, so that result may not be considered a hazardous waste if the asbestos is not friable and finely divided. Barium sulfate, if it is a form of barium sulfate that is insoluble, then it would not be considered a hazardous waste. And this is in, again, that document, the final statement of reasons in Title 22 when they were developing all of the thresholds. Because barium sulfate is used for its heaviness, its insolubility. So really what we're looking at is something's going to leach into a landfill, leach into soil. Barium sulfite is known for its insolubility. So you may have a result that's very high in barium, but if it's something that has barium sulfate in it, that result is being skewed by insoluble forms of barium. So again, getting back to it's important to know your source. And then molybdenum disulfide, it's the same thing. It's insoluble in water and dilute acids. So it's a black crystalline sulfide that occurs as a mineral, and it's only soluble in certain situations, and it's a problem for foliage and plants. So you're going to want to look at that MSDS or know more about that waste stream or the product that's producing that waste. If it has molybdenum disulfide in it, it may not be considered a hazardous waste because it is insoluble form of molybdenum. And you can find this information out by the MSDSs, looking at product information. doing a process flow diagram for your facility. And as a CUPA inspector, you would see how the facility is doing that, ask to see their MSDSs, ask them about their process. And then chromium, last thing, if it's soluble chromium as determined by the TCLP, and this is right in the footnotes, so it's right out of the rules. If it's less than 5 soluble chromium as determined by STLC, then the waste is a non-RCRA hazardous waste. So if it's less than 5 on the T-clip, but it's more than 560 on the STLC, then it's non-RCRA hazardous. What if it's more than 5 on the T-clip? It's RCRA hazardous, right? Right, okay, good. Now, if the T-clip for chromium is less than 5, the STLC is less than 560, it's not hazardous for chromium, according to the Title 22. Now, it may be hazardous for other stuff, but not for chromium. And that's what that footnote's about. So in trying this example, so the chromium TTLC limit is 2,500 milligrams per kilogram. That's the totals. So it's not hazardous for totals, right? It's below the threshold. Our result is 110. Okay, this is the results we looked at earlier. So we have 110 milligrams per kilogram chromium in this sample of bead blast waste as an example. So then we look at the totals first. It's below 2,500, okay. It's not hazardous for totals. Then we try the T-clip 20 times rule. We did that earlier, right? We divided it by 20. We had 5.5. And what did we say earlier? It's borderline. We might want to run, the T-clip on that. So we did. We ran the T-clip, and the result was non-detect. Here's the sample result right there at the bottom. You can't really see it there. So it's less than 5 for T-clip. It's less than the totals, so it's not a RCRA hazardous waste. We don't think it's a California hazardous waste. Would we need to run the STLC? Ten times rule, very good. Okay, so go back to the beginning. For a sample of waste containing soluble chromium, if the T-clip's less than 5, it's not RCRA. If RCRA doesn't apply, then the limit value for soluble chromium is 560. So if you have 110, it's below that. So you wouldn't apply the 10 times rule to that. It's way low. You know it's not going to come up for solubility. 110 is much less than 560. Okay? Yay! Okay. So then, in going through the rest of these, again, you would look at your MSDSs, look to see if you have these oral rat, or if you don't have this other sampling data, you can use this as a guide. For example, for acute inhalation, you could look at the MSDS and see that it has a dermal LC50. If it's less than 10,000 milligrams per kilogram, then that waste might be considered toxic. Okay, if that exhibits that waste, if the concentration would exhibit that. I have a couple of slides here on aquatic toxicity. So aquatic toxicity, LC50, lethal tox, 50% of the concentration dies. And I think I have a slide here coming up. So really, aquatic toxicity is, let's see here. Here we go. Okay, so this is a quick and easy test. And that's why a lot of times facilities use it, and CUPA inspectors might use it. But there are some limitations to this test. This is an example so that because the LD50 was less than 500, and you'll see that in the guidance document, that means that it's considered toxic. So this is 289.1, so that means it failed. So that means it's hazardous. That sample killed more than half the fish. But the problem, there's limitations. Amount of samples crucial. You have to make sure you take an accurate sample. The other thing to remember is they have to keep the fish alive. So they put bubblers in, and they adjust the pH of those tanks. So if you have a corrosive sample, you're seeing if it's toxic, they're adjusting the pH of that fish tank. So that could kind of skew your results a little bit. And then what about hydrocarbons? Do they sink in water? Miscible? They float. So, depending on the test conditions, having an oil-based sample might be, you may not have good data for that result. Okay, so let's talk about ignitability and fly through some of these other things real quickly. These, like I said earlier, these are simple. So, well, I should say simple, but for ignitability, you test the flash point. And it says right here that if it has a flash point of less than 140 degrees Fahrenheit, then it's considered ignitable. That's pretty simple. That's the test. The only trick with ignitability is that this test method is specifically designed for liquids. So if you want to use this test method for a solid to determine if something is a hazardous waste, the method is not designed for that. Some people do use the test method to test ignitability on a solid just to get information, but it's not really designed. That method isn't designed to test liquids, or I'm sorry, solids. And then, so the lower the number, the more ignitable the substance. You guys know that from chemistry. Okay, and I already talked about ignitable non-liquids. Just kind of remember that. I think about paint booth filters and testing for ignitability. It may not really be a valid waste determination. Corrosivity, pH. Does anybody know the numbers for pH? Yes, very good. Okay. So we're looking at a pH of less than or equal to 2 or greater than or equal to 12.5, or it's a liquid that corrodes steel. So those results that you get, it's the pH. You're going to look at those results. That's pretty simple interpretation. And there's our methods for checking for corrosivity towards steel. That also would apply. So this pH is 13.1. Is it hazardous? If there's no exclusions, then yes. Very good. Okay. And holding time is an issue with pH. Reactivity, there are no test methods. It's just knowledge of process. So that's going to be a little tricky. And if you guys look this section up, you'll see it's really all very subjective. There's no lab test for reactivity.
Is that a test?
What's that?
It looks like that.
Yeah, there's the test right there. Yeah, that's reactive. Exactly. Thank you. Okay, so, and this just talks about more about reactivity. So in looking at all these results, units are important, making sure you're comparing the numbers correctly. Okay, so we have a little quiz here, and we may not have time. I'll just have Kes pass out the candy to you guys real quickly so we can go through these questions. Does anybody need a piece of chocolate? Okay, yes, they want chocolate. Okay, good. All right, so we're running out of time here. Sorry about that. We'll be available if you guys have questions. Come on up at the end. So really the goal of sampling is the generator makes that determination. CUPA inspectors are verifying that waste determination. We're looking for making sure and see if a waste exhibits hazardous waste characteristics. There's all different types of lab analysis, different methods. Right now, we do not have test methods for reactivity. Some of the common pitfalls were why is it important to ensure thorough analysis, identifying waste. Tiered permitting, they would have to do sample analysis to determine if you meet LDR or exempt from LDR restrictions, land disposal restrictions, you might have to do analysis. But for the most part, it's not required for you to do analysis to make your waste determination. The limitations of pH are holding time, the temperature. Some things don't have a pH if there's no active hydrogen ions. Okay. Flash point, really, if it's a non-liquid is the main limitation. Sample preservation is definitely an issue with ignitable samples. All right. Table 1, 2, and 3, hopefully you guys will remember those acronyms. Okay. All right. So then all of our, terms, you guys know how to find those terms. How do you interpret lab results? Where do you start? Hopefully you have some information here. We all make mistakes. It's important to review those test method protocols. Remember exclusions. So something that's in the ground, it may not technically be a hazardous waste until it's excavated. So that's something to keep in mind. And of course, waste determination's generator's responsibility. And garbage in, garbage out. If you don't take good samples, if they're not representative or good authoritative samples, and you understand that it's an authoritative sample and the type of sampling you do, then you really can't adequately review your lab results. Patty, talk about, hop up here and talk about things labs don't like.
Please tell us if you're going to send us a nasty sample. A beaker full of concentrated nitric acid looks like a beaker full of water, which looks like a beaker full of pure benzene. You know, let me know if you're sending me something odd. It's not just some water. It's not just some soil. Don't send me a 5-gallon or a 50-gallon drum. I need, 20 mils, or I need a box, a cup of it, and that's it. Don't hold on to it too long. Don't send it warm. Call us and tell us, hey, I have this going on, and we'll give you all the information. We have containers, we have coolers, we have ice, we have anything that you need. We have chain of custody forms, and we have people to sit here and explain all the rules to you. So please, just call me and let me know.
Okay. And one more thing I just want to talk about. You guys have this in your slide notes, but it's really important. As a CUPA inspector, we have it's really important that we remember that we do not have the authority to force a generator to take a sample, and it's not really a good idea to try to give the generator the inspection, the feeling that they should sample, forcing them into it. But it's kind of a fine balancing point, because if the generator doesn't have enough knowledge about their waste, then they may need to sample. So you kind of have to balance that. And then also, once those results come in, it's important as a CUPA inspector to remember, we can't say, yes, this one sample you took, okay, now all your waste is non-hazardous. And I've had people do this where they write on the report, this waste is not a hazardous waste. The inspector's writing that. We don't have that authority. The generator makes that determination. So make sure you don't make that mistake. Right, as per the facility, this waste is not a hazardous waste. Make sure you add that terminology into your reports. Giving them guidance is good, that defining hazardous waste, but I've had this happen. I've told somebody, they knew nothing about their waste. They wanted to sample. I said, yeah, take a sample and take it to the lab. They ran STLC on every sample. They didn't know that they could just run TCLC first. And they spent a lot of money on this sample. So giving them a little bit of guidance is a good thing. And please feel free to give me a call if you have any questions. Sorry I went a little bit over, and thank you very much.